Hello everyone, this is Vijayasri, working as an assistant professor, Department of CSIT, MLR Institute of Technology. In this session, we are going to discuss about recursive functions in C. Overview of the session, function recursion, syntax of recursive function recursion with an example program. So before going into the discussion of the session, function recursion, first we'll recall what is a function, how to write a function. So how to write a function? When we are writing a function, make sure that it has a function declaration, function call and function definition. So what is function declaration? How will declare a function? Declaring a function is, syntax is return type, function name, data type, comma, data type, so on, and ended with a semicolon. Declaration is always ended with a semicolon. Declaration is done above the main function. Then function call. Syntax for function call is just a function name, and then here we'll write a list of parameters or arguments. List of arguments, or we can say parameters. This is also terminated with a semicolon. Then function definition, return type, function name, data type. For variable here I am considering var1, comma, data type, var2, so on. Function scope, here we'll write what this function has to do. This is a normal function. How we'll write a function? Then function recursion. What is a function recursion? In C programming language, function call can be made from the main function or other functions or from the same function. See, here we have called the function, we have made a function call inside the main, or we can call the function from other function or function itself. Function itself. The recursive function is defined as follows. A function called by itself is called recursive function. When a function calls itself is called recursive function. Let us suppose we'll go with the example. Return type is int, function name is sum. Here I am not writing any parameters, that means function, this comes under a category function with return type without argument. Then declaration must be terminated with a semicolon. Then always the declaration is done above the main. In the main we'll call the function just simply with the function name. Here I did not pass any arguments, so no need to write the arguments here. Then when we call the function, the control goes to function definition. Definition and declaration must be the same. That means the return type, function name, and how many arguments we are passing. Here the return type of the function is int, then the function name is sum. Here I am not passing any arguments, so here also did not mention. Then here we'll write what this function has to perform. Like coming to recursion, a function called by itself is called recursive function. A function called by itself, that means here the function is sum, that is calling itself. How it calls? Function call syntax is function name, and if we have any list of arguments we'll write. So here the function name is sum. So now this becomes a function recursion, means the function is calling itself. So again I'll write here int sum. This is a declaration. Declaration must be made above the main. Then function call with the function name, no parameters. When we call the function, the control goes to function definition. Definition and declaration must be the same, means the return type, function name, and whatever the arguments we are passing. Coming to function recursion, a function called by itself. Now the control goes to main. First, in a main we have a function call. So the control goes to the function definition. In the same function, in this function definition, we are calling the same function, sum. The recursive function should be used very carefully because when a function called by itself, it enters into infinite loop. Let us suppose here the function call happens in the main, so the control goes to function definition. In a definition, it performs something, then we have a function call. So again the control goes to function definition. So in a function definition, again I call the same function. So again it goes to function definition. So what it is repeating the same function. That means it enters into a infinite loop. When a function enters into infinite loop, the function execution never gets completed. So it is repeating again and again. Then when it has to stop or when it has to exit from that infinite loop, this stopping condition, when you are writing a stopping condition, you must be very careful where to stop this function call. So we will write this stopping condition in function recursion using if-else construct. When you should define a condition to exit from the function call so that the recursive function gets terminated. When you mention this condition to exit from the function call, then the recursion will get ends. So in simple words, recursion is nothing but a function called by itself is called recursion. Here the function is sum, it is calling itself. It is called, now this becomes a function recursion. When we are writing programs in a function recursion, make sure that when to stop the function call. This stopping condition must be written using if-else construct. Let us suppose, consider an example, like I want to find factorial of a, first we'll go with the syntax. So function declaration generally done above the main, then in a main we'll call the function. So the control goes to function definition. In a function definition, we are calling the same function. Let us suppose void, suppose here consider an example, void fun is the function name. I am not passing any parameters, so this fall under the category function without return type, without argument. Generally we will declare above the main. In a main we will call the function with its function name, no parameters. When you call this, the control goes to function definition. Definition should match with the declaration, means the return type of the function, function name, and how many arguments you are passing. Then in a function definition, we have again a function call, that means calling the same function itself. Here the function name is fun. Now this comes under function recursion. We are calling the same function. Now let us consider an example. Let us consider an example how to find factorial of a given number. Let us suppose I want to find a 5 factorial. Here the given number, let us suppose, is n. N is 5. I want a 5 factorial. How can we find a 5 factorial? Generally we will write 5 into 4 into 3 into 2 into 1. Or else we can write this. So 5 factorial, here I am writing 5 factorial, we can write this as 5 into 4 factorial. 4 factorial can be written as 4 into 3 factorial. 3 factorial can be written as 3 into 2 factorial. 2 can be written as 2 into 1 factorial. 1 can be written as 1 into 0 factorial. 0 factorial can be written as 0 into minus 1, minus 1, minus 1 into minus 2. Are we going like this? No. As I told you, whenever we are writing a program using function recursion, we must stop the function call at a condition by writing a condition using if-else construct. Where to stop? Either you can stop at 0 factorial. Why? Because we are stopping at 1. Either you can stop at 0 factorial or a 1 factorial. As we know that 0 factorial is 1, 1 factorial is also 1. By this, we are dividing the problem into sub-problems, like a smaller one, small problems. If I consider up to only 1 factorial, let us consider 1 factorial is my stopping condition. That means here n is 1. When we are stopping? When n becomes 1. When n becomes 1, what is 1 factorial? 1 factorial is 1. Let us suppose if n equal to 1, that means 1 factorial. 1 factorial, what it has to return? Return 1. If not, that means else. My n is not 1. N may be 5 into 4 factorial, n may be 4 into 3 factorial. So, here the stopping condition is 1. Because here we are stopping. And a factorial will calculate, if I want to calculate 5 factorial, it is 5 into 4 into 3 into 2 into 1. Where is the stopping condition? When n becomes 1. When n becomes 1, that means 1 factorial, then what is the value? 1 factorial is 1. So, when n equal to 1, it has to return 1. If not, that means else, n is not 1. N may be 5 into 4 or 4 into 3, 3 into 2. If I want to write this 5 into 4, how can I write? Else, 5 is nothing but a n, else n, this is n, where n is 5, n into 4. 4 means 5 minus 1, where 5 is n, that is n minus 1. So, this we can write as n into n minus 1, n minus 1 factorial. Now, so what is 1 factorial? 1. 2 into 1 is 2. So, 2 factorial is 2. 3 into 2 is 6. 3 factorial is 6. 4 into 6 is 24. So, 4 factorial is 24. 5 into 4 factorial is 24. It is 120. So, the 5 factorial is 120. So, let's see the same problem statement with an example. So, consider a stack frame. This is a memory layout. So, always the execution starts from main. First, we have to declare a function. Function declaration is return type, function name. How to declare a function? Return type, function name, then arguments, parameter list. Here we are finding factorial of a number. So, the function name is fact, the return type is int. How many inputs I am taking? Factorial of a number, only one number. So, it is the number of inputs are 1. So, the arguments are also 1. Of which data type? Integer type. So this is function declaration. Declaration is always terminated with a semicolon. So int is the return type of the function fact. Then how many arguments? That means how many inputs? One input of type integer. Then program execution starts from main. In main, where main is a function, so in my stack frame, one frame is allocated to the function main. Let us suppose this is one segment which is allocated to the function main. In main, what we declared? We declared result and n. Those are of type integer. So some memory is allocated where this is the integer type. Let us consider 4 bytes of memory is allocated to those variables. Those variables are result and n. So result n. Enter any integer. Let us suppose here I gave the integer is 5, which is provided by the user. So using a scanf function will read this input. So here n value is 5. N value is 5. Now result is equal to where this is comes under a function call. Function call syntax is function name. Then how many arguments? If you have any list of parameters, will pass. Here the function name is fact, as we declared in fact. Then how many arguments we are passing? Only one. Well, in function call, we'll just mention the variable name, not the data type. And that must be terminated with a semicolon. So that is stored. This function call is stored in the result. So what we have in result? In result, fact of n, where this is a function like a main. So some segment for main section, some memory is allocated to main. In the same way, some segment is allocated to the function fact of n, where n is 5. Here we gave n value is 5. So some segment is allocated to fact of 5. Now the control goes to function definition, where what is n value? N value is here 5. So definition must be the same with the declaration. That means the return type, function name and the arguments. Here the return type is int, where declaration is also the return type of the function is int. Then the function name is fact. How many arguments we are passing? Only one argument. Okay. Then in the function definition, n equal to, what is n value here? Here n is 5. If n equal to 1, here we have n where n is 5. N equal to 1, here n is 5. Is 5 equal to 1? No. So the control goes to else. This condition is false. So the control goes to else block. In else what we have? Return n into fact of n minus 1, where n is 5. 5 into fact. Here we are calling the same function. Fact n minus 1, where n is 5. 5 minus 1, so it is 4. Here we are calling the same function. This is a recursive function call. So again the control goes to function definition. But fact of 4 is like a fact of 5, where some segment in a memory, some segment is allocated to the function fact of 4. Now what is n value? N value is here now 4. So n is 4. Now we call the function. So the control goes to function definition and it has to perform the task what we have given in a function definition. So here n value is 4. Now if n equal to 1, that is n4, is 4 equal to 1? No, condition false. So the control goes to the false block of statement. In a false block, we have return n into fact of n minus 1, where n is 4 here. Where n is 4. 4 into fact of n minus 1. Where n is 4, 4 minus 1, now it is 3. Fact of 3. Now, fact of 3 is also a function call. Recursively, we are calling the function. Same function. Fact of 3, again, like a fact of 4, some memory segment is allocated to fact of 3. Now, what is n value? N value is now 3. In this segment, the n value is 3. Is 3 equal to 1? No. So, the control goes to false block of statement. In false block, we have return n into fact of n minus 1, where n is 3. So, 3 into fact of n minus 1, 3 minus 1, now it is 2. So, return 3 into fact of 2, where fact of 2 is like a function, like a fact of 3. So, some more one segment of memory is allocated to fact of 2. Now, n value is 2. 2. Again, it is a function call. Fact of n minus 1 is recursively we are calling the function. Here, n value is 2. In this segment, n value is 2. Is 2 equal to 1? No. So, the control has to execute the else block of statement. In else, we have n into fact of n minus 1, where n is 2. 2 into fact of n minus 1, that is 1. So, here 2 into fact of n minus 1, that is 1. Again, fact of 1 is like a function, like a fact of 2. So, one more segment is allocated to fact of 1. Now, n value is 1. Again, we are calling fact of 1 is a function call. So, the control goes to function definition. In this segment, n value is 1. Now, if n equal to, in this segment, n value is 1. If n equal to 1, what is n here? 1. 1 equal to 1. Here I am return 1. N equal to, because 1 factorial is 1. So, that I consider n equal to 1. When n becomes 1, it has to return 1 because 1 factorial is 1. Return 1. Where it has to return? Where called that? Fact 1 is called by fact 2. So, it has to return to the function where it is called. So, fact of 1 value is now 1. So, 2 into 1 is 2. 2 into 1 is 2. 2 is the value for the fact 2 function call. Where, who called that fact 2? Fact 2 is called by fact 3. So, it has to return here where the function called. So, fact 2 value is 2 now. 3 into 2 is 6. 6 value is, 6 is the value for fact of 3. Actually, fact of 3 is called by fact of 4. So, it has to return back to where it is called. So, fact of 3 value is here 6. Now, 4 into 6 is 24. 24 is the value for the function fact of 4. Fact of 4 is called by fact of 5. So, the fact of 4 has to return back to the function where it is called. So, entire fact of 4 value is now 24. So, 5 into 24 is 120. Actually, fact of 5 is called in the main. Where? In the main result section. In the result. So, fact of 5 is now 120. So, now fact of 5 is 120, which is stored in the variable result. If we want to print the factorial of 5, then printf result. Then to print the value, use the predefined function printf. Factorial is, where this is a integer type, so the format specifier is %d, comma, result. So in this way, we have to return back recursively where the function is called. So consider this example, the same. Here we call the function, always the function declaration. Function declaration must be done above the main. So the control goes here, then the n value is 5, here n is 5. This is a function call, so the control goes to function definition. So n is 5, is 5 equal to 0, so return 1, it will not return 1. So the control goes to else block of statement. Now 5 into fact of 5 minus 1, that is 4. 5 into fact of 4. Again it is a function call, so the control goes to function definition. Now 4, is 4 equal to 0? No. So it has to return else block. The control enters into the false block of statements, that is n into, where n is 4. Fact of 4 minus 1, it is 3. Where fact of 3 is a function call again. So the control goes to function definition. So is 3 equal to 1? No. So else block of statement, fact of 2. Now 2, is 2 equal to 1? No. So it has to perform else block, fact of 1. Now is 1 equal to fact of 1, it is a function call. Here n is 1. N equal to, we can take, is n equal to 1? Yes. So 1, if n equal to 1, it has to return 1. It has to return 1. Where it has to return, where it is called. So this is 1. 2 into 1, now it is 2. This is 2. 3 into 2 is 6. 4 into 6 is, so fact of 4 is 24. 5 into 24, so it is 120. So here we got factorial of 5 is 120. Here I consider a condition like base condition, exit condition, or we can say stopping condition or a base condition. We must be careful while we are writing the condition, otherwise the function call enters into infinite loop. Here I consider if n equal to 0 or n equal to 1, return 1. Return 1, because 0 factorial is also 1, 1 factorial is also 1. So I consider both the conditions. So in this way, we'll go with the function recursion. So in this session, we discussed about function recursion and we have seen a sample program. In the next session, we'll see about the storage classes. Thank you.